Good morning all. In this session, let us discuss some of the examples on network parameters. That is analysis of two-port network parameters. This is from Module 5 of the subject Network Theory. Table of contents, numerical analysis, multiple choice question links and references. The problem is find the impedance parameters of the network shown below. Impedance parameters nothing but Z parameters. So for this network, we have to find all four impedance parameters. Z11, Z12, Z21 and Z22. And if we observe this network consisting of two sources, voltage source and current source, and both sources are dependent sources. Here if we consider the current source, the value of current source is 2 into V3, that is 2V3, where V3 is the voltage across 2 ohm resistor, what we can see here, and the value of voltage source is 2I2, that is output put current, that is I2, 2I2, and this network consisting of three loops. So by representing I1, I2 and I3 are three currents through these three loops respectively, and by applying KVL to all the three loops, so we can find all different Z parameters. So I am considering here I1 is the current through loop 1, I2 we can see in the next slide here. I1 is the current through loop 1 and I2 is loop 2 and I3 is current through loop 3. And I3 consisting of current source, that is 2 times of V3. So I3 becomes 2V3, and by applying voltage law through these loops, we can see in the next here. So equation 1 is the value of V3. So V3 is, we know that it is voltage across 2 ohm resistor, and the current through 2 ohm resistor is I1 plus I2, because this 2 ohm resistor is common to two loops, loop 1 and loop 2, and both the currents are flowing, that is I1 current and I2 current, both the currents are flowing in the same direction. So the current through 2 ohm resistor is I1 plus I2. Therefore, V3 becomes 2 into brackets I1 plus I2. I have written, we can see here in the equation number 1. By applying Kirchhoff's voltage law to the mesh 1, 2I1 plus 2I2 plus 2 times of I1 plus I2 is equal to V1. And by the simplification, 4I1 plus 4I2 is equal to V1. Say equation number 2. Similarly, by applying Kirchhoff's voltage law for the mesh 2, see, if you see the mesh 2 here, mesh 2 consisting of two resistors, 2 ohm resistor and another 2 ohm resistor, and this 2 ohm resistor, that is, which is common to both I2 loop and I2 and I mean loop 2 and loop 3. So current through this ohm resistor is I2 minus I3, because I3 and I2 are flowing in the opposite direction, and the current through this 2 ohm resistor is I1 plus I2, and by applying Kirchhoff's voltage law to this loop, we get, that is 2 times of I2 minus I3. I am replaced, I have replaced here I3 as 2V3 plus 2I1 plus I2 is equal to V2, and I have taken 2 inside the bracket and simplified, and we get minus 6I1 minus 4I2 is equal to V2. So let's call this as equation number 3. Now let's find all the parameters of Z one by 1. So Z11, according to the definition of parameter Z11, it is a ratio of V1 by I1 when I2 is equal to 0. So V1, the value of V1 is 4I1 plus 4I2. That is equation number 2. By substituting equation number 2 over here, that is 4I1 plus 4I2 divided by I1. So when I2 is equal to 0, that is by putting the value of I2 is equal to 0 in this, we get 4I1 by I1 get cancelled. So the value of Z11 is 4 ohm. Now let us find the value of Z21, which is the ratio of V2 and I1, that is V2 divided by I1 when I2 is equal to 0. V2, the value of V2 is equation number 3. What we can see here, equation number 3, that is minus 6I1 minus 4I2 is equal to V2. So let us substitute here, minus 6I1 minus 4I2 divided by I1 when I2 is equal to 0. Put I2 is equal to 0 here. We get minus 6I1 divided by I1 get cancelled. The value of Z21 is minus 6 ohm. Now Z12 is ratio of V1 by I2 when I1 is equal to 0. So we know that V1 is 4I1 plus 4I2 and let us divide it by I2. Divided by I2 when I1 is equal to 0. By substituting I1 is equal to 0 here, we get Z12 is 4 ohm. Similarly, Z22 can be found by using the equation or formula V2 divided by I2 when I1 is equal to 0, and V2 is minus 6I1 minus 4I2 divided by I2 when I1 is equal to 0. Substitute I1 is equal to 0. We get minus 4I2 divided by I2. I2 get cancelled. So Z22 is equal to minus 4 ohm. So value of Z11 is 4, Z21 is minus 6, Z12 is 4 and Z22 is minus 4. All are in ohm. So let's see another example wherein we have to find Z and Y parameters. So find Y and Z parameters for the network shown below. If you observe this network, it has got current dependent current source. So let's go for nodal analysis. And here I have identified two nodes, node 1 and node 2. As usual, one more node, that is reference. Now let us apply KCL to node 1 and node 2. If you see the node 1, we have 3 branches to node 1, and if you see the node 2, we have 4 branches to node 2. And by applying KCL to both the nodes node 1 and node 2, and by simplification we get, that is at node 1 1.5 V1 minus 0.5 V2 is equal to I1. Say this is equation number 1. At node 2 minus 0.5 V1 plus V2 is equal to I2 minus 3 I1 is equal to, that is nothing but, which is equation number 2. Let me repeat once again, that equation number 2 minus 0.5 V1 plus V2 is equal to I2 minus 3 I1. So by writing these two equations, equation number 1 and equation number 2 in the matrix form, we get 1.5 minus 0.5 minus 0.51 should be multiplied by the column matrix V1, V2 is equal to coefficients of I1 and I2, nothing but 1, 0, minus 3, 1 with a column matrix I1, I2. Now I just take I just take this particular matrix, the right side of the equation. So we get inverse of this. So V1, V2. V1, V2 column matrix is equal to 1.5 minus 0.5 minus 0.51. Its inverse should be multiplied by the matrix 1, 0, minus 3, 1 into column matrix I1, I2. Then by multiplying these two matrices, we get minus 0.4, 0.4 minus 3.2, 1.2 into I1, I2. Therefore, if you compare this with the standard matrix notation of Z matrix, so Z parameters are minus 0.4, 0.4 minus 3.2, 1.2. So these are Z parameters. And to find Y parameters, we need to take the inverse of this matrix, because Y parameter nothing but admittance parameter, which is the reciprocal of Z. So we need to take its inverse matrix. So we get Y is equal to inverse of Z, that is 1.5 minus 0.5, 4 minus 0.5. So this is the required parameter. So next one is determine H parameter, nothing but hybrid parameters of the network shown here. If you observe this network, this is a pi or a delta network. So one way is to directly we can find out H parameters, or else I have converted this pi or delta network to star network. See, we can see in the next slide. See here, I have converted it to star network. So the performing delta to star transformation, we can see the previous network like this. Since here we have all three resistors same, that is 12 ohm, and here we have got all resistors present in star network are same, that is 4 ohm resistor. So now let us find H parameter for this network. We know that H11 is given by V1 by I1 when V2 is equal to 0, and H21 is the ratio of two currents, that is I2 by I1 when V2 is equal to 0. So in here we need to short the output port, because here V2 is 0. We can see in the circuit diagram, I have made V2 to 0 and I have kept rest 3 variables I1, V1, I2 as it is. And if you observe this circuit, when we short the output port, here this 4 ohm resistor and this 4 ohm resistor, they come in parallel, and that equivalent resistor comes in parallel with this 4 ohm resistor. So if you apply here KVL, V1 is equal to I1 into brackets 4 ohm plus parallel combination of 4 ohm and 4 ohm. By simplifying this particular thing, we get, that is V1 by I1 is equal to 6 ohm. That is H11 is V1 by I1 when V2 is equal to 0 is 6 ohm. Now to find out H21, we just apply current division method or current division principle. Here I'm interested in current I2, that is current through this 4 ohm resistor. So current through this 4 ohm resistor is main current into resistor of another branch divided by sum of the resistors. And here I have taken minus I2 because it is flowing in the opposite direction. So minus I2 is equal to I1 divided by 4 plus 4 into 4. Therefore, by simplifying this equation, H21 equals I2 divided by I1 when V2 is equal to 0 is minus 1 divided by 2. So to find H12 and H22, open circuit the input port. So by input port, we should open it. Nothing but we should make I1 to 0. And by applying principle of voltage division, V1 is equal to V2 divided by 4 plus 4 into 4. So H12 is V1 divided by V2 when I1 is equal to 0. So this is 1 divided by 2. So similarly, V2. V2 is equal to 4 plus 4 into I2. So 4 plus 4 into I2, because the current through the 4 ohm resistor is I2 since I1 is 0. So V2 is equal to 4 plus 4 into I2 is equal to 8 I2. So H22 is equal to I2 divided by V2 when I1 is equal to 0 is 1 divided by 8 sin or mho. So the next problem is determine Y parameters for two-port network if Z parameters are 10, 5, 5 and 9. Here is given Z parameters and we need to find Y parameters. One way is we can take its inverse, or another way is by using relation between Z and Y parameters. We know that Y11 is given by Z22 divided by delta Z, where delta Z is Z11 into Z22 minus Z21 into Z12. The value of delta Z is, by substituting all these, the value of delta Z becomes 65 and Y11 is equal to 9 divided by 65. Yes. Similarly, Y12 is minus Z12 divided by delta Z. So, minus Z12. So, Z12 is 5 here, 5 ohm. So, minus 5 divided by 65 is minus 5 by 65. S is Y12. And Y21 is minus Z21 divided by delta Z is equal to minus 5 divided by 65. Yes. And Y21 is equal to, Y22 is equal to Z21 divided by delta Z is 10 divided by 65. Yes. Now, let's see another problem wherein we have hybrid parameters and we need to determine Y parameters, and hybrid parameter matrix is 5, 2, 3, 6. So delta H should be found first, that is H11 H22 minus H21 into H12, By substituting all the parameters of h is we get delta h is equal to 224. So y11 is given by 1 divided by h11 is equal to 1 divided by 5. Yes. Y11 is 1 by 5. Yes. Y12 is minus H22 divided by H11 is equal to minus 6 by 5. Yes. And Y21 is ratio of H21 by H11 is equal to 3 by 5. Yes. And Y22 is equal to delta H divided by H11 is equal to 24 by 5. Yes. So these are some of the examples, some more examples on two-port network parameters. And this is the MCQ link. These are references. Thank you.